Let us practice how to graph parabolas. To graph a parabola, in the previous school year, we just need the vertex and 4 additional points. That means we just need 5 points. But right now, even if we just need to look at only for the vertex, the focus, the directrix, and even the ends of the lattice rectum, we can now graph a parabola. For the previous videos, we were just looking at parabolas in standard form where the vertex is located in the at the origin. But right now, in numbers 1 and 2 here, these are not found, the vertices are not anymore found in the origin or at the origin. Why? Look at the value here. For number 1, this is now in the form of a binomial as well as the x variable rather. And for number 2, we have additional values here for x, which is actually the one with the second degree exponent. If you say something like this, again, the vertices are not anymore found on the origin. Our goal here is to determine what are the vertices. The standard form for parabolas where the vertices are not on the origin are given to be either x minus h, the square of x minus h rather, the square of x minus h is equal to 4p, and then you have here y minus a. This is actually somewhat similar when we talk about equation of a circle in the previous lesson, wherein the vertex now is not at 0, 0, but is somewhere on the coordinate of h and k, where h is the coordinate or the value for the x coordinate, and k is the value for the y coordinate. If that is the case, we can now determine the value or the yes, the value for the vertex here for our standard form from our standard form, which is given to be, or let me write here at the top, the vertex is now h and then k. This is just for the first form. The second form is when we reverse or revert the uh, what they call this, the variables. Instead of the x minus h being squared, we have the y minus k, and then you have 4p x minus h. Take note that x and h will always go together since h is the x coordinate of the vertex, and y will always be with k because k is the x coordinate of the vertex. So do not say y minus h here and x minus k. That would be incorrect later. So again, these are the correct two forms. Let's use these forms to determine first the vertex and probably later on the concept of P to get their focus, directrix, and ends of the lattice rectum. Number 1 is in the form where the binomial that is being raised into an exponent of 2 is with y variable. So instead of the first figure, let's use the second, sorry, rather, the first form, we will have the second form. And that would be y minus k, or the square of y minus k is equal to 4p. And you have here x minus h. Take note that our vertex is still h and k, regardless of whether the variable y, the binomial with the variable y is being raised into exponent of 2, or whether it's the exponent or the variable x that is being with the binomial with the variable x which is being squared. Doesn't matter, it's still h and k. So in this case, we know that k is 3. But our age is not easily, I mean, do not jump into conclusion immediately that our age is 2 because the standard form should be minus. This means that this form here may be rewritten as this: y minus 3 squared is equal to 16. And then x, revert the double negative property, x minus negative 2. In this case, we are now following the minus symbol here, or subtraction symbol. And then our h is not 2, but more importantly, it's negative 2. So our vertex is at hk. That's k. So it is actually the vertex at our h is not 3. Again, it's please make sure of the proper notations. It's actually negative 2 and then 3. This is where our vertex is. Let's just plot it on our Cartesian plane here. So the vertex is at negative 2 and then 3. So you have negative 2 and then positive 3. Our vertex is here. Let's use the green color because the vertex is green as we used this color before. Again, it's not anymore on the in the origin, at the origin rather. It's very far from the origin. So that is now, this is now the time that it's time for us to analyze more as to what should it look like. Next, we are going to get the focus, directrix, and the ends of the lattice rectum. All of these three uses P. And then, therefore, we need to get P first. How do we get P? Simply compare this with that, H minus K, and this. That would mean 4P is 16. So you have here 4P is equal to 16. Therefore, P is equal to 16 divided by 4, 4. This is the value for our P. With this value, we can use this to get our focus. The focus will not be using the concept of 0p or the other way around p0, okay? Please be guided that our focus is collinear or on the same line with our vertex. Since our vertex is here, so it's either our focus should either be here or there or here or there, depending on what would be the form later. But if you talk about 0p, it's somewhere here. So dili pwede diri. Okay, it's not okay there. Sorry. I use vernacular. So it's not for here. It's only for either or between or among these four directions here. Let us review your module as for the correct form of the focus for your parabola that is with the vertex not anymore located on the origin. The formula for the focus is to be determined first by the direction of the parabola. Okay, it's not asked here, but we need to identify first the direction of the parabola to help us where could we locate the focus, because if we know that it's opening upward or downward, we would know that the focus is on the interior of the opening of the parabola. Well, look at our given. It is with the variable y that is being squared. This is a signal that is either opening to the sides, okay, either to the left or to the right. Trimming it down, look at the coefficient here, positive 16. It's a positive coefficient. That would mean our parabola should open towards the right. Again, the giveaway is y being squared, so it's sidewards. If it's x being squared, so it's up and down. And then the coefficient here, if it's positive to the right, if it's negative to the left. So if it's to the right, okay, or opening sidewards, our equation or our formula for getting the focus is actually equal to P. Okay, let me write it here. The focus is at P plus H and then K, because it is our H that is being uh, changed. Okay, P plus H, oh, and then comma K. So we have here our H and K earlier here. Let's try to substitute. The focus is our P value is 4 plus H, which is negative 2, and then you have K 3. So 4 plus negative 2, that's positive 2. Our focus is at positive 2, sorry, and then 3. If you're going to plot this here, 2 and 3, it's somewhere here. 1, 2. 1, 2, 3, the focus is here. Assuming that that is correct, and we know that the focus is located on the interior of our parabola, it is a further proof that it really opens towards the right, as our claim earlier that the graph is. Okay? But this is not yet the final graph. Let me change this first. Okay? Again, we are now safe to say that it's actually really opening towards the right because the focus is here. For the directrix, okay, the directrix is directly opposite the focus. So we have the same distance, 1, 2, 3, 4. It should also be 1, 2, 3, 4. This area here is where you will find your directrix. The formula, if you would like to follow the formula for the directrix, is for equations that is opening right or left. We have here the equation x, sorry, let's use red, x is equal to h minus p. Minus because on the opposite, it's on the opposite side. But anyway, the p value will give us what we need. H is negative 2 minus p, which is 4. So the equation x is equal to negative 6 is where our directrix is. Let's look at our assumption earlier. We have the same distance, 1, 2, 3, 4, 1, 2, 3, 4. And since its focus is here, and then if it's the focus is here, therefore this is the axis of symmetry because it's opening towards the right. So if this is the axis of symmetry, the directrix is perpendicular, so it's vertically here, which is actually passing through this value of x at the bottom. What is the value for your x here? 1, 2, 3, 4, 5, 6, opposite side, negative. So you have here x is equal to negative 6. And by the way, we have the same here, x is equal to negative 6. I forgot to place some notations. Let me complete here. Our focus is at 2, 3, and our vertex is located at negative 2 and then 3. And negative 2 and then 3. Okay, we're almost done. We are done with directrix in the vertex. Let's go to the ends of the lattice rectum. The lattice rectum should contain the focus. So it's somewhere here. It's somewhere in this area, which is also parallel to the directrix, but it will contain the I mean the focus of our parabola. We do have also a formula in determining the lattice rectum. You don't need to memorize this. You may always focus on our module or refer to our module for opening towards right and left. Our ends of the lattice rectum are given to be p plus h, comma, plus minus 2p plus k. 2p plus k. So if we're going to break that 2, you have p plus h and then negative 2p. Let me rewrite this one. Negative 2p plus k for the first. The second, we have p plus h and the positive 2p plus k. We already have h and k here. We also have p. Let's continue and substitute, and let's see if our latus rectum is really this side, and if it contains the endpoints that we will get later. Okay, so we have here the values for p. 4, h is negative 2, comma, negative 2 times p, which is 4, plus k, which is 3. Okay, and then for the second, we have 4 plus negative 2 for h, comma, 2 positive 2 times 4 and plus k, which is 3. 4 times negative 2 plus negative 2 is positive 2. Here, 2 times negative 4 is negative 8 plus 3, negative 5. Okay? So and then you have here 4 plus negative 2 is positive 2. And then 2 plus times 4 rather is 8 plus 3 is 11. So if we're going to plot this in our Cartesian plane here, 2, negative 5, 1, 2, 1, 2, 3, 4, and 5. It's somewhere here. And then for 211, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it almost cover all of our graphing paper here. So the lattice rectum is somewhere in this area with ends at, okay, let me write here the ends. The ends at 211. This means this is your top end. And at 2, negative 5, this means this is your bottom end. If you're not convinced, you can always check by getting the lattice rectum. Okay, it's not here, but if we're going to solve the ends of the lattice rectum is again that has the formula, okay, equal to the absolute value for p. For p, so p is given earlier as 4. This is actually 4 times 4, so that's positive 16. Absolute value of 16 is 16. Let's check if the blue colored lattice rectum really has 16 units. 1, 2, 3, 4, 5, 6, 7, 8. That's half of the distance. Focus towards this. And then 9, 10, 11, 12, 13, 14, 15, 16. That means this correct checking is correct. Now, we could just simply connect our graph. And what should we connect here? Take note that the ends of the lattice rectum are parts of the parabola. So from the vertex, it should open to that area there. And it should also pass here. Okay, just assume that my graph is accurate somewhere like that. Okay, so this is now, if assuming that it's the graph is almost perfect, that is our graph for number 1. Number 2, we'll use another process. Let's watch the next video for this. Please stay tuned. Goodbye.